Before we begin, if you enjoy calm journeys through space and gentle stories of the universe, you're warmly invited to subscribe and stay with us. These quiet explorations are made for long nights, curious minds, and peaceful rest. Now, take a slow breath and allow the noise of the day to fade. Tonight, we drift far beyond familiar skies, past the last lights of our home galaxy, into regions where time itself feels thin and distant. For nearly a century, humanity has carried a simple story about the birth of everything. A universe born from a single beginning, a moment of fire, expansion, and light. A story known as the Big Bang. It is a story that has guided our understanding of stars, galaxies, and the slow unfolding of cosmic time. A story taught in classrooms, written in textbooks, and whispered into countless documentaries. But the universe, as it often does, has quietly offered something unexpected. With eyes more sensitive than any before, the James Webb Space Telescope has begun to see farther back in time than we ever thought possible. It has captured ancient light that has traveled for more than 13 billion years, just to reach us, here, now. And in that ancient glow, astronomers noticed something unusual: galaxies that seemed too mature, too structured, too complete. For a universe so young, not a loud contradiction, not a dramatic collapse of ideas, just a soft tension, a gentle question forming in the dark. Tonight's journey is not about proving anything wrong. It is about listening carefully as the universe reveals another layer of its story. So settle in, let your thoughts slow, and together we'll explore the quiet discovery that invites us to rethink how the cosmos first began. Chapter 1. Before the first light. Long before stars learned how to shine, before galaxies traced their slow spirals across the dark, there was only silence. Not the kind of silence we know on Earth, but a deeper quiet, a stillness where time itself had not yet begun to flow in any familiar way. When we speak of the universe's beginning, we often imagine an explosion, a violent burst, something loud, sudden, and overwhelming. But the truth, as scientists have slowly come to understand, is far more subtle. The Big Bang was not an explosion in space. It was the expansion of space. There was no center point flying outward into emptiness, no cosmic fireball pushing debris into a waiting void. Instead, space itself began to stretch, everywhere at once, quietly, uniformly, carrying energy, matter, and possibility along with it. In those earliest moments, the universe was unimaginably hot and dense, so dense that atoms could not yet exist, so hot that even light could not travel freely. Everything was packed together in a state we can barely describe, using words borrowed from a world that came much later. Time ticked forward, not in seconds or minutes, but in fractions so small they almost escape meaning. As the universe expanded, it cooled, and in that cooling, structure slowly became possible. First came the simplest particles, then protons and neutrons. Then, after hundreds of thousands of years, the first atoms formed: hydrogen, helium, the lightest elements, the quiet building blocks of everything that would follow. Only then could light finally move freely through space. That ancient glow, released when the universe became transparent, still surrounds us today. It is known as the cosmic microwave background, a faint whisper of heat spread evenly across the sky, a lingering echo of the universe's earliest breath. For decades, this gentle afterglow served as powerful evidence that the universe truly had a beginning. From this foundation, scientists built a timeline, a story of gradual growth. First, darkness. Then, the first stars igniting after hundreds of millions of years. Then, small galaxies forming, merging, slowly assembling into larger, more complex shapes. Nothing rushed, nothing fully formed too soon. The early universe, according to this picture, was a patient place. Stars needed time to be born, to live, to die, and to seed space with heavier elements. Galaxies needed time to gather mass, to organize their swirling arms, to grow central bulges and stable structures. Everything unfolded step by step, guided by gravity, governed by simple physical laws, played out across vast stretches of cosmic time. This story fit beautifully with what we could observe. Our telescopes, limited by distance and technology, showed us nearby galaxies in rich detail, and distant ones as faint, blurred shapes. The farther we looked, the younger the universe appeared. And so, the idea settled in quietly. The earliest galaxies should be small, messy, irregular, incomplete drafts of what galaxies would later become. For many years, this expectation went unchallenged, not because scientists were certain, but because the universe had not yet revealed otherwise. Until, at last, humanity built an eye capable of seeing deeper. An eye designed not for visible light, but for infrared, the stretched, reddened glow of ancient stars, their light elongated by billions of years of cosmic expansion. This eye would not just look far away, it would look back in time, and with its first glimpses into the early universe, the calm, patient story of gradual formation began to feel slightly unsettled, not broken, not overturned, just gently disturbed, like a still lake touched by a single falling leaf. As we move forward, we begin to notice something unexpected, waiting quietly in the deep past, something that asks us to slow down, to look again, and to listen more carefully to the universe's oldest light. And so, with the foundation laid, we drift onward, toward the first galaxies themselves, and the surprising shapes they revealed far earlier than anyone anticipated. Chapter 2: When Darkness Learned to Gather. After the universe released its first light, after space cooled enough for atoms to exist, a long, quiet era followed. An age without stars, without galaxies, without any sources of light at all. Cosmologists call this time the Cosmic Dark Ages. It was not dark because something had gone wrong, but because nothing had yet learned how to shine. Hydrogen and helium atoms drifted silently through expanding space, spread thin by the steady stretching of the universe. Gravity, though present everywhere, was still gentle, too weak to force immediate change. Yet even in this apparent stillness, tiny imperfections already existed. In some regions, matter was ever so slightly denser than average. In others, slightly thinner. Differences so small they would be invisible to the human eye, but large enough for gravity to notice. Over millions of years, these subtle imbalances began to matter. Where density was just a little higher, gravity pulled more strongly. Gas drifted inward, slowly, patiently, drawing more matter into these growing pockets. This was not a violent collapse. It was a gradual gathering, a quiet organization of chaos. As gas accumulated, pressure and temperature began to rise at the centers of these clouds. Atoms collided more frequently. Energy built up. Eventually, after tens of millions of years, something remarkable happened. The first stars ignited. These were not stars like our Sunday. They were enormous, many times more massive, burning hot and fast, living brief, brilliant lives. When they switched on, they ended the cosmic dark ages. Light flooded into a universe that had never seen it before. Ultraviolet radiation streamed outward, ionizing surrounding hydrogen, changing the very state of cosmic matter. This era is known as cosmic reionization, a slow awakening of the universe, as starlight reshaped space itself. But stars do not form in isolation. They gather in groups, bound together by gravity, sharing the same reservoirs of gas. These early stellar neighborhoods were the seeds of galaxies. At first, they were small, chaotic, irregular. Gravity had not yet smoothed them into elegant spirals or glowing ellipses. There were no stable disks, no orderly arms, no calm rotations, only clusters of intense, short-lived stars, burning within clumps of gas. As the first stars lived and died, they forged heavier elements in their cores. Carbon, oxygen, silicon. When they exploded as supernovae, they scattered these elements into space. This enrichment changed everything. Gas clouds with heavier elements cool more efficiently. They collapse faster. They form stars more readily. With each generation of stars, the universe became better at making new ones. Galaxies began to grow, not all at once, but through countless small mergers. Tiny proto-galaxies collided and combined. Some were torn apart. Others merged smoothly. Gravity slowly stitched these fragments into larger systems. According to long-standing models, this process took time, hundreds of millions of years, before galaxies became massive. 1 billion years or more before they developed stable shapes. This gradual timeline felt natural. It matched computer simulations. It matched indirect observations. It matched the patient rhythm of cosmic evolution. When astronomers looked far away using older telescopes, this picture held. Distant galaxies appeared faint, blurred, often irregular. Their light, stretched and dimmed by expansion, carried little detail. What could be seen seemed to agree. Early galaxies were small and disordered. Nothing suggested urgency. Nothing suggested maturity. And so, confidence grew quietly. The universe, it seemed, had followed a gentle path from simplicity to complexity, from darkness to light, from chaos to structure. But there was always a limit, a boundary beyond which we could not see clearly. Even the most powerful telescopes, before James Webb, struggled to observe the earliest galaxies in detail. Infrared sensitivity was limited. Resolution was constrained. Astronomers knew they were missing something, not because theory was flawed, but because their view was incomplete. They were reading the universe's oldest chapters through frosted glass. James Webb was built to change that. Designed to unfold in space like a golden flower, its mirrors were tuned to capture faint infrared light. The stretched glow of ancient stars shifted into longer wavelengths by cosmic expansion, light that left its source when the universe was only a few 100 million years old, light that had been traveling ever since, silently crossing billions of light years. When Webb finally opened its eyes, it did not rush. It stared. Long exposures, deep fields, patient listening, and slowly, images emerged. Galaxies appeared, not as vague smudges, but as defined structures, shapes, brightness, unexpected clarity. Some were small, as predicted, but others looked strangely complete. They had central concentrations. They showed symmetry. They appeared massive. Too massive, some wondered, for such a young universe. According to the established timeline, there simply hadn't been enough time for gravity to build these structures so quickly. The universe was supposed to still be learning how to assemble itself. And yet, here were galaxies, already standing tall, not perfect, not modern, but far from primitive. This did not feel like a contradiction shouted across the cosmos. It felt like a quiet inconsistency, a soft nudge, as if the universe was saying, "You may want to look again." In science, such moments are not crises. They are invitations. An invitation to refine assumptions, to question timelines, to test whether unseen processes moved faster than expected. Perhaps star formation was more efficient. Perhaps mergers happened earlier. Perhaps feedback from early stars behaved differently. Or perhaps, and this possibility lingered silently, our understanding of the earliest moments was incomplete. Nothing had collapsed. No theory had shattered. But the calm, gradual story had developed a subtle tension, like a melody with a note that lingers just slightly off-key, drawing the listener's attention. As we continue our journey, we will follow that tension more closely. We will sit beside the data, listen to the debates unfolding quietly among scientists, and explore why this discovery does not destroy the Big Bang, but instead invites us to understand it more deeply. And so, we drift onward, toward the telescope itself, and the silent way it changed what we thought we knew about the universe's first billion years. Chapter 3. The telescope that listens to ancient light. High above Earth, far beyond clouds and weather, beyond the moon's steady pull, there is a quiet point in space where gravity holds its balance. This place is known as the second Lagrange point, L2. Here, the gravitational influence of Earth and the Sun aligns in a delicate harmony, allowing an object to orbit the Sun while remaining in step with our planet. It is here, 1.5 million kilometers from Earth, that the James Webb Space Telescope waits in silence. Webb does not circle Earth like Hubble once did. It travels with us, shielded from heat and light, always keeping its back to the Sunday. This distance is not a matter of ambition. It is a necessity. To see the earliest galaxies, Webb must detect infrared light, radiation so faint that even the slightest warmth from Earth could overwhelm it. And so, Webb carries with it a sunshield the size of a tennis court, 5 thin layers of reflective material designed to block heat, allowing the telescope's instruments to cool to near absolute zero. In this deep cold, Webb listens. Unlike traditional telescopes, it does not search for bright stars or glowing nebulae alone. It listens for stretched light, photons that began their journey billions of years ago, when the universe was young and dense. As space expanded, those photons were stretched with it, their wavelengths lengthened. Visible light slipped into infrared. This phenomenon, known as redshift, acts as a cosmic timestamp. The more stretched the light, the older its source. Webb was built to read this stretching with precision, to separate the faint whispers of ancient galaxies from the foreground noise of closer stars. When its first deep-field images were released, they stunned the world. Not because they were loud or dramatic, but because they were crowded. Galaxies filled the frame, thousands of them, each a distant island of stars, each representing a different era of cosmic history. Some of these galaxies existed when the universe was less than 1 billion years old, and among them, astronomers noticed something unexpected. Several appeared far brighter than models had predicted. Brightness alone does not reveal age or mass, but it raises questions. Brightness suggests many stars. Many stars suggest large amounts of gas. Large amounts of gas imply significant gravitational assembly. In other words, these galaxies seem to have grown up very quickly. Follow-up observations sharpened the picture. Spectral analysis revealed strong signals, indications of mature stellar populations, chemical enrichment, and surprisingly high star formation rates. Some galaxies showed evidence of heavy elements that should have taken multiple generations of stars to produce. Others appeared massive enough to rival galaxies much older in the nearby universe. All of this pointed to a quiet puzzle. How did these galaxies assemble so fast? The standard cosmological model does not forbid early structure, but it assumes certain efficiencies: how quickly gas collapses, how stars form, how feedback from radiation and explosions slows further growth. If those assumptions are slightly off, galaxies could form earlier than expected. But how off? Computer simulations were rerun, parameters adjusted, star formation efficiencies increased, feedback weakened. Some models began to reproduce the observations, others struggled. This was not a failure of science. It was science doing exactly what it is meant to do. Observations lead, models follow. But beyond the technical discussions, something deeper was unfolding. Webb was showing us the universe, not as we imagined it, but as it actually was. And reality, as always, was more subtle than our stories. Some early headlines declared that the Big Bang was broken or disproved. But among astronomers, there was no panic. The Big Bang is not a single fragile idea. It is a framework supported by multiple independent lines of evidence: cosmic expansion, background radiation, elemental abundances. Webb had not contradicted these foundations. Instead, it had illuminated a chapter we had only partially read. The earliest galaxies, it seemed, were not clumsy first drafts. They were ambitious beginnings. Dense regions of space may have collapsed faster. Dark matter halos may have formed earlier or more efficiently. Gas may have cooled and condensed with greater speed than anticipated. None of these possibilities break the Big Bang. They refine our understanding of what followed it. In this sense, Webb did not rewrite the opening line of the universe's story. It expanded the middle. It reminded us that a beginning does not dictate a pace, that even in a young universe, complexity can arise quickly when conditions allow. Still, the feeling lingered, a gentle unease. If galaxies matured earlier than expected, what else might we be misunderstanding? Were our timelines too conservative? Were unseen processes accelerating growth? Or was there something fundamental we had yet to notice? Science advances not by loud revolutions, but by quiet accumulation. One observation at a time, one anomaly carefully examined. Webb's discoveries did not demand that we abandon the Big Bang. They asked us to look closer at the era just after it, to study the relationship between dark matter and gas, to refine our models of star formation, to question how rapidly order can emerge from simplicity. And so, in laboratories and observatories around the world, astronomers returned to their data, not with fear, but with curiosity. They measured redshifts more precisely. They mapped galaxy masses. They compared simulations to reality. Each step brought clarity and more questions. Because every time humanity builds a better eye, the universe responds by revealing deeper layers. Webb, in its quiet orbit, does not announce conclusions. It offers evidence. It listens to ancient light and passes that story to us, untouched by expectation. As we absorb these discoveries, we begin to understand something important. The Big Bang was never meant to explain everything at once. It explains the beginning. What follows is a long, evolving story, still being written. And in the next chapter of our journey, we will explore why tension between observation and theory is not a threat to science, but the very reason it continues to grow. For now, we let the telescope remain where it is, listening patiently as the universe continues to reveal its earliest memories. Chapter 4. Tension, not collapse. When new observations arrive, especially ones that reach farther back in time than ever before, it is tempting to think in absolutes. Either a theory stands, or it falls. But science rarely moves in such sharp motions. It stretches, it adjusts, it breathes. The discoveries made by the James Webb Space Telescope did not strike cosmology like a sudden crack of thunder. They arrived more like a slow change in the weather, noticeable only to those who were paying close attention. Galaxies appearing earlier than expected, brighter than predicted, more massive than models had comfortably allowed. These findings created tension, but not panic. To understand why, we must pause and consider what the Big Bang theory actually is, and what it is not. The Big Bang is not a detailed blueprint. For every galaxy, star, and planet, it does not specify how quickly each structure must form, or how efficiently matter must organize itself. Instead, it describes the universe's earliest state and its large-scale evolution. It explains why space is expanding, why distant galaxies are moving away from us, why the universe is filled with a faint, uniform glow of ancient radiation, why hydrogen and helium dominate cosmic matter. These pillars remain untouched. James Webb did not observe a universe that is not expanding. It did not detect a background radiation inconsistent with predictions. It did not find elemental abundances out of place. What it revealed lies after the beginning, in the era when gravity took over and matter began to assemble. This is where uncertainty has always lived. Galaxy formation is one of the most complex problems in modern astrophysics. It involves gravity, gas dynamics, radiation, turbulence, magnetic fields, and the invisible scaffolding of dark matter. Small changes in any of these processes can produce large differences in outcomes. For decades, scientists relied on simulations to fill the gaps left by observation. These simulations were not guesses. They were carefully constructed models based on known physics. But models, by their nature, must simplify. They approximate feedback processes. They average behaviors. They make assumptions about efficiency and timing. James Webb offered a chance to test those assumptions against reality, and reality responded with nuance. Some early galaxies, it turned out, may have formed stars more efficiently than previously assumed. Gas clouds might have cooled faster. Star formation might have proceeded in intense bursts rather than gradual waves. In dense regions of the early universe, dark matter halos could have collapsed quickly, drawing gas inward with surprising speed. If even a few of these processes operated slightly differently, the timeline shifts. Not dramatically, but enough to matter. What once required 1 billion years might only need a few 100 million. From a human perspective, this feels enormous. From a cosmic perspective, it is subtle. There is also the question of interpretation. When astronomers infer the mass of distant galaxies, they do so indirectly. They measure light, they analyze spectra, they model stellar populations. These methods depend on assumptions about how stars form, how bright they are at different ages, and how dust absorbs light. If early stars behaved differently, if they were more massive, hotter, or shorter-lived, then mass estimates could shift. What appears to be a mature galaxy might be a younger system, burning unusually bright. This possibility is not an escape route. It is a reminder of humility. We are interpreting ancient light through layers of theory and inference. Webb has sharpened the image, but interpretation remains a human task. There is also the role of selection. The first galaxies Webb observed were among the brightest and most massive of their time. These are the ones easiest to detect. Fainter, smaller galaxies, perhaps far more numerous, remain below the detection threshold. Our early view of the young universe may be biased toward its most extreme examples. Seeing only the tallest trees does not mean the forest was entirely made of giants. As more data accumulates, a fuller picture begins to emerge. Some early galaxies were indeed massive and structured. Many others were not. The universe, as always, was diverse. This brings us to an important truth, often missed outside scientific circles. Tension between theory and observation is not a flaw. It is the engine. When predictions and data disagree, scientists do not discard frameworks lightly. They investigate the mismatch. They ask where assumptions may be too rigid, where parameters may be too narrow, where physics may be incomplete. Sometimes this leads to minor adjustments, sometimes to major breakthroughs. But collapse is rare. The Big Bang itself was once such a tension. Before it was widely accepted, observations of galaxy redshifts did not align with a static universe. The idea of expansion challenged long-held beliefs. It took decades of evidence to reshape consensus. Now, the process repeats, not at the foundation, but in the details. There are even more speculative ideas being discussed quietly. Could dark matter behave differently in the early universe? Could interactions between radiation and matter be more complex than we thought? These questions are explored cautiously, not as declarations, but as possibilities. No single observation rewrites cosmology. Patterns matter, consistency matters, and so far, the pattern remains coherent. A universe that began hot and dense, expanded and cooled, formed structure under gravity. What Webb has shown is that this process may have been more efficient, more dynamic, more creative than our earlier models suggested. This does not weaken the story, it enriches it. There is a quiet beauty in this moment. We are witnessing science in motion, not as conflict, but as conversation. Data speaks, models respond, understanding deepens. The universe is not defending itself. It is not arguing. It is simply revealing what has always been there. And as we listen more carefully, we begin to appreciate that certainty is not the goal, clarity is. In the final part of our journey, we will step back and reflect on what this moment teaches us, not just about the universe, but about how knowledge itself evolves. Because sometimes the most profound discoveries are not those that shatter our beliefs, but those that gently remind us how much more there is to learn. Chapter 5: How Science Grows in Silence. When the universe offers new information, it rarely does so with urgency. There are no announcements written across the sky, no signals meant to persuade or convince. There is only light, ancient, patient, carrying the quiet memory of distant events. Science exists to listen to that light, not to rush toward conclusions, but to sit with uncertainty long enough for patterns to emerge. The discoveries made by the James Webb Space Telescope have reminded us of this discipline. They have not overturned our understanding of the universe's beginning. They have deepened our appreciation for how complex the path from simplicity to structure truly is. In this sense, the story unfolding now is not about the Big Bang itself, but about what came next, about the first billion years, a span of time so vast that human language struggles to contain it, yet so brief in cosmic terms that entire galaxies seem to have grown in its shadow. Science advances by layering insight upon insight. The Big Bang theory did not appear fully formed. It was shaped over decades by observation, debate, refinement, and doubt. It survived not because it was protected, but because it consistently aligned with reality. Each new instrument added detail. Each new survey tested its limits. James Webb is simply the latest voice in a long conversation between humanity and the cosmos. What makes this moment special is not the challenge itself, but the way it is being met. Astronomers did not rush to declare victory or defeat. They examined their tools, rechecked calibrations, expanded sample sizes. They asked whether brightness truly meant mass, whether early stars behaved differently, whether unseen populations of faint galaxies balanced the apparent excess of large ones. This patience is not hesitation, it is respect. Respect for the complexity of nature, respect for the limits of interpretation, respect for the fact that knowledge grows most reliably when allowed to breathe. There is a common misconception that science moves in sudden revolutions, old ideas destroyed, new ones crowned overnight. Reality is quieter. Most progress comes from small corrections, from narrowing uncertainties, from recognizing where models oversimplify reality. In this case, the Big Bang remains the opening chapter, but the early pages that follow are being rewritten with finer detail. The universe, it seems, was more capable than we imagined. It could organize itself quickly under the right conditions. It could produce light, structure, and complexity without waiting for long, drawn-out timelines. This realization does not diminish the wonder. It increases it. A universe that can build galaxies so swiftly is a universe rich with possibility, and that possibility extends beyond cosmology. The way we respond to these discoveries reflects something fundamental about human curiosity. We are not searching for comfort. We are searching for truth, and truth is rarely simple. It unfolds gradually, often contradicting expectations, without contradicting reality. there is also humility in this process. Every generation of scientists inherits a partial picture. They refine it, extend it, and pass it forward. James Webb will not be the final word. Future telescopes, even more sensitive, even more precise, will continue the conversation. They will look deeper, see fainter, measure more accurately. Some ideas will be strengthened, others will soften, a few may quietly fade away. This is not failure, it is growth. In a sense, science mirrors the universe it studies. It expands, it cools, it organizes itself over time. Errors are not explosions, they are corrections. Misunderstandings are not collapses, they are invitations. The universe does not demand certainty from us, only attention. And so, as we reflect on what James Webb has shown us, we can rest in a simple understanding. The Big Bang was not broken, it was clarified. The universe's story has not ended. It has become richer, more nuanced, more alive. We now see that the early cosmos was not a slow, hesitant place, but a dynamic environment where gravity, light, and matter worked together with remarkable efficiency. This knowledge does not close doors, it opens them. It invites new questions about dark matter, about the nature of early stars, about the speed at which order can arise, and it reminds us that the universe is not obligated to match our expectations. It exists as it is, patient, vast, unconcerned with human timelines. As listeners to its story, our role is not to rush ahead, but to follow gently, adjusting our understanding as needed. In the quiet orbit where James Webb listens, there is no urgency, only light arriving, one photon at a time, each carrying a fragment of a story, older than Earth itself. As this journey draws to a close, we are left not with answers carved in stone, but with a deeper calm. A sense that knowledge is not something we conquer, but something we approach, slowly, carefully, with wonder. And in that calm, perhaps the greatest discovery of all emerges. The universe is not fragile. Our theories are not brittle. They are living frameworks, growing alongside our ability to see. And as we rest beneath the quiet sky, we can take comfort in knowing that every new question brings us closer to understanding our place within this vast, unfolding cosmos. Chapter 6. Listening to what comes next. When a discovery settles, when the first waves of excitement fade, what remains is something quieter and far more important. Attention. The universe does not reveal itself all at once. It speaks in fragments, in faint signals, in patterns that only emerge. After long periods of listening, James Webb has begun a conversation, not a conclusion. Its early observations have reminded scientists that the first billion years of cosmic history were not merely a prologue, but a complex chapter filled with rapid change, hidden efficiency, and unexpected maturity. Yet this chapter is still being read. Every observation raises new questions. Every answer opens another door. If galaxies formed earlier than expected, what conditions made that possible? Was dark matter more influential in the early universe than our models assume? Did gas cool faster due to unknown mechanisms? Were the first stars fundamentally different from those that formed later? These are not dramatic mysteries, they are precise ones. And precision is where science thrives. In the coming years, James Webb will continue to stare into the past, targeting galaxies even closer to the moment when the first stars ignited. It will measure their spectra more carefully, estimate their masses with greater accuracy, separate light from stars, gas, and dust. With increasing confidence, patterns will begin to form. Some early claims will soften, others will strengthen. The universe will clarify itself, not because it is changing, but because we are learning to see more clearly. This is how progress happens, not in leaps, but in refinement. There is also a broader shift underway. Cosmology is moving from a field limited by observation to one guided by abundance. For the first time, astronomers are not struggling to find early galaxies. They are struggling to understand the sheer number of them. This abundance changes perspective. Instead of asking, can galaxies form this early? We begin to ask, how common was this process? Instead of focusing on anomalies, we search for distributions. The early universe becomes less mysterious and more statistical. And with statistics comes stability. Extreme examples no longer dominate the story. They find their place within a broader context. The universe stops feeling surprising and starts feeling consistent again. Not because it matches old expectations, but because new expectations take shape. This process is ongoing, and it is deeply human. We build instruments. They show us something unexpected. We pause. We adapt. At no point does the universe rush us. It has waited billions of years to be observed. It will wait longer still to be understood. There is a quiet lesson in this patience. Knowledge does not demand certainty. It rewards curiosity. The Big Bang Theory, like all strong scientific frameworks, has endured not because it resists change, but because it accommodates it. It has absorbed new data before: dark energy, accelerated expansion, inflation. Each addition did not weaken the theory. It made it more complete. James Webb's discoveries belong to this tradition. They do not rewrite the beginning. They enrich the middle. They remind us that the universe's earliest epochs were more active, more capable, and more complex than our early models allowed. And that is not a failure of imagination. It is its growth. As future observatories join this effort, radio telescopes mapping hydrogen across cosmic time, ground-based giants peering deeper into infrared, space missions refining cosmic background measurements, the picture will continue to sharpen. What feels uncertain now will feel familiar later. What feels surprising will become expected. This is not the end of a story. It is the settling of a rhythm. The universe began hot and dense. It expanded. It cooled. Structure emerged. Within that structure, variation flourished. Some regions moved faster, some slower. Some galaxies grew rapidly, others lagged behind. Together, they formed the cosmos we see today. In this light, the phrase "breaking the Big Bang" loses its power. Nothing has broken. Something has been understood more deeply. And perhaps that is the most comforting realization of all. The universe is not fragile. Our understanding is flexible. It bends without snapping. It adjusts without erasing. As we conclude this journey, we return to the quiet from which we began. A vast sky, ancient light, a universe that does not demand answers, only attention. Tonight, as you rest beneath that sky, whether clouded or clear, remember that every star you cannot see is still there. Every answer we do not yet have is still forming. The cosmos does not rush. Neither must we. We listen, we wait, and slowly the story continues to unfold. Chapter 7. A beginning that keeps unfolding. When we speak of beginnings, we often imagine something fixed, a single moment, a clear line between before and after, a door that opens once, then closes forever. But the universe has never worked that way. Its beginning was not a point we can circle neatly, nor a chapter we can finish reading and set aside. It was the start of a process, one that has been unfolding ever since, quietly, patiently, across distances too large for intuition, and times too long for memory. What the James Webb Space Telescope has shown us is not that our story of the universe was wrong, but that it was incomplete in the way all early stories are. We understood the outline. Now we are learning the texture. The early universe was once imagined as a slow learner, hesitant, fragile, taking its time to find structure and rhythm. Webb has suggested something different, a universe that adapted quickly, that gathered itself with surprising confidence, that formed stars and galaxies, not reluctantly, but eagerly, as soon as conditions allowed. This does not make the universe feel chaotic. It makes it feel capable. In this light, the Big Bang is not diminished. It is reframed, not as a distant, explosive event, locked away in the unreachable past, but as the first breath in a long, continuous exhale. Everything we see today, every galaxy, every star, every atom in our bodies, is part of that same motion. The universe did not finish beginning. It is still becoming. This realization carries a quiet philosophical weight. If the universe could organize itself so quickly, if complexity could emerge so early, then perhaps order is not as rare as we once thought. Perhaps structure is not an exception, but a tendency. Given space, given time, given simple rules, gravity pulls, energy flows, patterns form. This is not just a cosmological insight. It is a reminder of how nature works at every scale, from galaxies assembling in the dark, to storms forming in an atmosphere, to thoughts taking shape in a human mind. Order does not arrive fully formed. It grows, sometimes faster than expected, sometimes slower, but always through interaction, through tension, through balance. The debate sparked by Webb's discoveries is not really about whether the Big Bang is correct. It is about how comfortable we are with uncertainty. Science, at its best, does not fear being wrong. It fears being rigid, the willingness to adjust, to say, "We did not know this yet," is not weakness. It is maturity. In that sense, cosmology today mirrors the galaxies it studies, still forming, still refining, still responding to new information. No single observation defines the whole. No single theory captures everything. Understanding emerges from accumulation, from comparison, from patience. James Webb is a powerful tool, but it is not an oracle. It shows us what is there. It does not tell us what to think. That responsibility remains ours. And so, scientists will continue their work, measuring, modeling, revising. Some early claims will fade into nuance. Others will grow stronger with time. The universe will remain vast enough to accommodate both surprise and consistency. For those of us listening from afar, there is comfort in this balance. We do not need final answers to feel connected to the cosmos. We need only curiosity. The stars above us tonight are not frozen relics. They are participants in an ongoing story. Light leaves them, travels for millions or billions of years, and arrives here, quietly, without urgency. We receive it not all at once, but moment by moment. In that way, understanding is like starlight. It does not rush, it accumulates. And perhaps that is the deeper lesson of this chapter in our exploration. The universe is not something to be solved. It is something to be accompanied. We walk beside it with our instruments, our equations, our questions. Sometimes we catch up to its rhythm. Sometimes we lag behind. But the journey continues. As this chapter draws to a close, we find ourselves not at an ending, but at a widening horizon. The beginning of the universe was not a fragile idea, waiting to be broken. It was a doorway, and beyond it lies a landscape, still revealing its depth. James Webb has opened our eyes to how much richness existed, even in the universe's youth. And in doing so, it has reminded us that every beginning contains more than we first imagined. The night sky has not changed. The stars still rise and set. The cosmos remains vast and calm. What has changed is our listening. We have learned to hear fainter signals, to sit longer with questions, to accept that understanding is a slow, shared journey. And so, we rest here for a moment, not with certainty, but with quiet wonder, because the universe is still speaking, and we are still learning how to listen. Chapter 8. The quiet meaning of an expanding story. There comes a moment in every long exploration when the questions begin to soften, not because they have all been answered, but because they have found their place. The discoveries of the James Webb Space Telescope have carried us to such a moment. What began as a technical observation, galaxies appearing earlier, brighter, more structured than expected, has gradually unfolded into something deeper. Not a crisis of cosmology, but a reminder of how understanding truly grows. When humanity first looked up at the night sky, the universe felt distant and unchanging. Stars seemed fixed, patterns eternal. Only much later did we learn that everything above us is moving, expanding, evolving. The Big Bang gave us a way to think about that motion, a beginning that explained why space stretches, why light reddens, why the universe carries a faint memory of its earliest heat. James Webb has not erased that beginning. It has brought us closer to what followed it, and in doing so, it has invited us to reflect not only on galaxies and stars, but on the nature of knowledge itself. There is a temptation, especially in modern times, to expect clean answers, clear victories, definitive endings, but the universe does not offer itself that way. It reveals layers. Each new instrument peels one back, only to show another beneath. What Webb has shown us is that the early universe was not merely waiting to become complex. It was actively becoming so. Structure did not hesitate. Light did not delay. Gravity did not stumble. As soon as conditions allowed, matter gathered. Stars ignited. Galaxies assembled. This does not contradict the Big Bang. it completes it. It tells us that a beginning does not determine how slowly or quickly a story must unfold, only what is possible. And possibility, it turns out, was abundant. This realization carries a quiet emotional weight. For centuries, we imagined the early universe as fragile, a delicate newborn cosmos, taking tentative steps towards structure. Now we see something else, a universe that was resilient from the start, capable of organizing itself with surprising confidence. There is something comforting in this. It suggests that order is not rare, that complexity is not an accident. Given the right conditions, the universe seems inclined to build. This inclination echoes far beyond astronomy. In every domain we study, from biology to climate to consciousness, we see the same pattern. Simple rules, repeated interactions, emerging structure. The cosmos is not a static machine. It is a process, and we are part of that process. The atoms in our bodies were forged in stars that formed long after the first galaxies, yet followed the same fundamental laws. Gravity pulled, energy flowed, patterns emerged. In that sense, learning more about the universe's youth is also learning something about ourselves, not in a poetic way alone, but in a literal one. Our existence depends on the universe's ability to organize matter efficiently. If galaxies had formed too slowly, stars might not have lived long enough to create heavier elements. If structure had been delayed, there would be no planets, no chemistry, no life. The fact that galaxies formed early is not just a curiosity. It is part of the reason we are here to notice it. This does not make the universe feel purposeful in a human sense, but it does make it feel coherent. The laws that shape the first galaxies are the same ones that shape the present moment. They have not changed. Our understanding has, and that understanding will continue to change as new data accumulates. Some interpretations will sharpen, others will soften. The story will become less dramatic, but more accurate. This is often the fate of genuine discovery. The initial surprise fades, replaced by integration. What once felt disruptive becomes normal. This does not diminish its importance. It confirms it. James Webb's observations will eventually be absorbed into a refined picture of cosmic history. Textbooks will be updated, simulations improved, timelines adjusted. The Big Bang will remain. Galaxy formation models will evolve, and the universe will continue to do what it has always done: exist, unconcerned with our interpretations. There is humility in this realization. We do not impose meaning on the cosmos. We extract it carefully, knowing it may change. Certainty is provisional. Curiosity is permanent. Perhaps this is why cosmology feels so calming when approached slowly. It reminds us that even our most fundamental ideas are not rigid. They are adaptable. They grow as we grow. The universe does not punish us for misunderstanding it. It simply waits. And when we build better tools, it shows us more. As we sit with these thoughts, the night sky becomes something different. Not a collection of distant objects, but a record of ongoing creation. Every point of light is a chapter still unfolding. Every discovery is a reminder that knowledge is not a destination, but a path. James Webb has taken us a little further along that path, not by shouting answers, but by offering evidence, not by breaking theories, but by inviting refinement. And in that invitation, there is peace. We are not late to understanding the universe. We are right on time, arriving at the pace our tools allow. The story of the cosmos will never be finished, but it will continue to reveal itself to those willing to listen quietly. And in that listening, perhaps the greatest insight emerges. The universe does not rush, neither should we. We learn, we adjust, we continue, just as the cosmos has done since its very first moments. Chapter 9. What it means to know a universe in motion. As our journey nears its end, the questions we carry feel different than when we began. They are no longer sharp or urgent. They are spacious. James Webb did not give us a final answer about the origin of everything. Instead, it offered something more enduring, a deeper relationship with uncertainty. To know the universe is not to hold it still. It is to understand it as movement. From the moment space began to expand, nothing has remained fixed. Galaxies drift apart. Stars are born and fade. Light stretches, quietly changing its color as it travels. Even our theories participate in this motion. They expand with new evidence. They cool as excitement settles. They reorganize as understanding deepens. The Big Bang theory itself has followed this path. It began as a radical idea, a universe with a beginning. Over time, it absorbed observations, weathered challenges, and grew more refined. Inflation was added. Dark energy entered the picture. Details sharpened. James Webb's discoveries are part of this same evolution. They do not stand apart from the theory. They move within it. To some, this may feel unsettling. We often want knowledge to feel complete. But completeness is not the same as truth. Truth, in science, is provisional. It holds until better evidence arrives. This is not weakness. It is strength. A rigid idea can shatter. A flexible one adapts. The universe we are learning about is not fragile. Neither is our understanding of it. There is also something deeply human in this process. We are creatures who ask questions, not because we expect certainty, but because curiosity is part of who we are. We look outward to understand inward. When we learn that galaxies formed early, that structure emerged quickly, we are reminded that complexity does not always need long delays. Sometimes, given the right conditions, remarkable things happen swiftly. This insight resonates beyond astronomy. In our own lives, growth does not always follow neat timelines. Understanding can arrive suddenly. Change can happen quickly. After long periods of quiet preparation, the universe mirrors this pattern. For millions of years after the Big Bang, little seemed to happen. Then stars ignited, galaxies assembled, light transformed space. From stillness, activity emerged. James Webb has allowed us to witness that transition with unprecedented clarity. And yet, even now, much remains unseen. There are galaxies too faint to detect, processes too subtle to measure, interactions too complex to model fully. This is not a failure of observation. It is a reminder of scale. The universe is large enough to outpace our instruments, and it always will be. This realization does not diminish science, it grounds it. We are participants, not masters. Listeners, not authors. The cosmos speaks through light, and we interpret as best we can. Sometimes our interpretations change. The light does not. As future telescopes come online, as data accumulates, the picture will continue to sharpen. Early galaxy populations will be mapped, star formation histories refined, timelines adjusted. What now feels like a mystery will become a chapter with footnotes, and new mysteries will take its place. This cycle is not endless repetition, it is progress. Each turn of the spiral brings us closer to coherence, not finality, but clarity. Perhaps this is the deeper lesson of cosmology in the Webb era. We are not seeking to lock the universe into a single explanation. We are learning how to stay open to what it reveals. Openness requires patience. It requires restraint. It requires comfort with ambiguity. These are not traits, often celebrated in a fast world, but they are essential when listening to something as vast as the cosmos. As we reflect on the phrase, breaking the Big Bang, it becomes clear how misleading it is. Nothing was broken. A perspective was expanded. The universe did not contradict itself. It showed us more of itself, and we adjusted accordingly. This is how understanding deepens. Not through confrontation, but through conversation. The cosmos speaks. We listen. We respond with revised models, refined questions, and renewed curiosity. In this quiet exchange, there is beauty. Not dramatic beauty, but enduring beauty. The kind that does not fade when excitement passes. As we prepare to rest our minds, to let the stars fade into dreams, we can carry one gentle truth with us. The universe is not finished explaining itself, and neither are we finished learning. There will always be more light arriving, more data to interpret, more stories to tell, and that is not something to rush. It is something to appreciate, because in a universe that never stops moving, the act of understanding is itself a form of motion, slow, careful, endlessly unfolding, just like the cosmos we are trying to know. Chapter 10. Resting Inside an Unfinished Universe. As our journey gently comes to a close, we return to the quiet from which it began. Not to silence, but to a deeper calm. After traveling billions of years through light and time, after listening to galaxies form and theories evolve, we find ourselves in a universe that feels less resolved and more welcoming. The James Webb Space Telescope did not give us certainty. It gave us perspective. It showed us that even our most foundational ideas are not rigid monuments, but living frameworks. The Big Bang was not a brittle story waiting to be broken. It was the opening note of a long, evolving composition. What followed that note was not chaos, but creativity. Matter gathered, light ignited, structure emerged sooner than expected, not because the universe rushed, but because it was ready. In this understanding, the early cosmos becomes something different. Not a fragile newborn, but a capable beginning. This does not diminish the wonder of the Big Bang. It deepens it. A beginning that leads quickly to complexity, suggests a universe rich with potential. A universe whose laws invite structure rather than resist it. And those same laws still operate now, quietly shaping stars, guiding galaxies, and sustaining the delicate conditions that allow us to exist. There is comfort in continuity. The processes that built the first galaxies are the same ones that shape the night sky above us. Nothing essential has changed, only our understanding. Science does not promise final answers. It promises better questions, and James Webb has delivered them. Questions about efficiency, about timing, about how quickly order can emerge from simplicity. These are not threatening questions. They are enriching ones. They remind us that knowledge grows best when curiosity remains gentle. There is a temptation, especially at the end of a story, to seek resolution, to close the book, to declare understanding complete. But the universe does not offer endings, only pauses, moments where we gather what we have learned and prepare to listen again. The story of the cosmos will continue long after us. New stars will form, old galaxies will fade, light will keep traveling, carrying information across expanding space, and future minds, human or otherwise, will look up and ask their own questions. Perhaps they will inherit our refined theories and push them further. Perhaps they will discover something we cannot yet imagine. This is not uncertainty to fear. It is continuity to trust. An unfinished universe is not a broken one. It is an open one. And openness is what allows meaning to keep unfolding. As we rest within this understanding, we can let go of the need for absolute conclusions. We do not need the universe to be simple, to feel connected to it. We need only to recognize that we are part of its ongoing story. The atoms in our bodies were shaped by stars. Those stars were shaped by galaxies. Those galaxies emerged from the early universe, now being revealed by James Webb. There is no separation. We are not observers standing outside the cosmos. We are expressions of it, briefly aware. And in that awareness, there is peace. The universe does not rush us. It does not demand certainty. It invites attention. So as this final chapter settles, we allow ourselves to rest. To accept that understanding does not need to be complete, to be meaningful. To appreciate that every answer is a doorway to deeper curiosity. And perhaps that is the most restful thought of all. We live in a universe that is still becoming, still explaining itself, still unfolding. There is no need to hurry. The stars will wait, the light will arrive, and the story will continue, quietly, patiently, just beyond the edge of what we know. For now, we close our eyes, not on an ending, but on a pause, a gentle pause, inside an unfinished universe. A quiet return from the stars. As the last light of this journey fades, we return gently from the depths of space to the stillness of the present moment. The universe remains vast, ancient, and unfinished, just as it has always been. Nothing was broken, nothing was lost. Only our understanding grew a little wider. The James Webb Space Telescope did not close a chapter in cosmology. It opened a quieter one, a chapter written not in certainty, but in patience. A reminder that the universe does not reveal itself all at once, and that knowing is not about rushing toward answers, but about learning how to listen. Tonight, as the stars continue their silent motion overhead, you can rest in the knowledge that curiosity is enough. You do not need to solve the universe to belong within it. Every question you hold, every moment of wonder, is already part of the same unfolding story that began billions of years ago. So let your thoughts slow. Let the vastness soften into calm, and allow the night to carry you gently toward rest. The universe will still be there when you wake, patient, expanding, and quietly waiting to be listened to again. Good night.